Hello everyone, welcome to this online training programme for the National Plant Monitoring Scheme. It's been prepared by me, Sue Bell, a chartered ecologist and aquatic botanist. This session is going to give you an introduction to freshwater habitats, fine habitats and species. I'm guessing that if you've joined in to this session, you're probably somebody who feels less confident in identifying freshwater plants and species. What I hope to cover during this session are how you can go about identifying the different types of freshwater that you need to record for the scheme, how to identify the different habitat zones associated with freshwaters, to give you an understanding of what factors influence which species you will find. Most importantly, I want to give you the confidence and ability to identify some of the species that you need to record, particularly those at the wildflower level, and an understanding of where there may be difficulties or the potential for confusion between similar looking species. To help us along our way, during this session I'm going to use a number of small keys to help distinguish between different sorts of habitat and different types of similar species. These keys have been designed specifically for this training programme, so may not be more widely applicable. So let's make a start with the habitats. You can record either at the broad habitat level, which is freshwaters, as shown at the top of the diagram, or you can record fine habitats. These are rivers and streams, nutrient-poor lakes and ponds, and nutrient-rich lakes and ponds. Freshwater habitats come in lots of different shapes and sizes. They cover running and standing waters. They include small ponds up to massive water bodies such as Loch Ness. While ponds are included within the recording scheme, small pools in peatland should be recorded as part of peatland habitats. Running waters can include small streams, becks, burns, as well as large tidal rivers such as the Mersey and Thames. It will also include ditches. Canals are also included within the recording scheme, and these are counted as standing water sites. Sites where there might be large fluctuations in water level between seasons should be excluded. This might include things such as temporary pools in sand dunes, seasonal rivers, fluctuating meres, turlows, man-made lakes, reservoirs, and saline and brackish lagoons and lakes affected by tides. This slide just shows you some of the variation in water bodies that you might encounter during your survey. This session is focusing on freshwater habitats, so we need to be able to distinguish these from saline or saltwater habitats. That might sound quite easy, but it can sometimes be a little tricky once you're out on site. The best approach is to take a look at an Ordnance Survey map before you go out on site. If we look at the slide, we can see an example of a key from an OS 1 to 50,000 map. If you look on the right-hand side, you can see a dark black line which delimits the extent of the normal tidal limit and saline influence within the coastal area and extending for a short distance upstream into the freshwater. If you look at the top of the slide on the left-hand side, you can see the loch, which marks the upper limit of the tidal influence. And if you look just below that, you can see that there's a bridge on the river, where again there's a dark line up as far as the bridge, which illustrates that there's some tidal influence there, and above the bridge would be a freshwater habitat. For the National Plant Monitoring Scheme, the area on the canal upstream of the loch would be counted as freshwater habitat, and on the river and the lake above the bridge are also both called freshwater habitats. Here's an example of a site that you might find. If you looked at this, would you be able to determine whether it was freshwater or whether or not it had some saline influence? There are a number of things you can look out for that will help to give you a clue as to whether or not you've got some form of saline influence. you can see whether or not there are obvious signs of a fluctuating water level, such as this green algal strip here. You can look to see whether you're finding seaweed species in the lake or river, and also things like extensive beds of this Norfolk reed can also be an indication of some form of saline influence. Okay, so let's assume we're happy that our water body is a freshwater body. We then need to go on to consider what sort of fine habitat it is. Generally, we divide freshwaters into two categories depending on flow. We have the running waters on the left-hand side and the standing waters on the right-hand side. For the purposes of NPMS, running waters are all treated together in the rivers and streams category, which is listed on the left at the bottom of the diagram. Standing waters, however, are divided into two broad categories depending on what nutrients levels they contain. They're either considered to be nutrient-poor lakes and ponds or nutrient-rich lakes and ponds, and we'll talk a little bit more about what that means in a moment. Running waters is a very broad category, but in all cases, the watercourses are characterised by having a perceptible flow or movement of water. It includes small becks, burns, streams, as well as very broad, wide, deep, slow-moving rivers. So it's a very variable category. There might be a variety of substrates, very rocky, very plant-poor watercourses, or they might be characterised by lots of silt and sediment and very dense beds of vegetation. Don't include any watercourses which are seasonal in nature or which aren't large enough to accommodate a 1 metre wide plot from the bank. When you're looking at flow, just be aware that a weir on a watercourse can cause slowing of the flow, or what we call ponding, just upstream of the weir. Standing waters is also a very broad category, as can be seen by looking at the selection of photos included on the slide. As with streams, you should exclude any water bodies which are seasonal in nature, or which suffer from a great deal of seasonal drawdown, such as reservoirs, or any sites which are affected by the tides. Canals are included within the standing water category, as they don't tend to have a natural perceptible flow, although there may be water movement caused by boats. Apart from water flow, one of the most important factors in influencing the species that you will find are the levels of nutrients within the water body. And we need to have an understanding of nutrient levels to help make that distinction in fine habitat between nutrient-poor lakes and ponds and nutrient-rich lakes and ponds. So on this slide, I've shown that we have a gradient of nutrient levels naturally in water bodies, from very low levels at the left-hand side to very high levels at the right-hand side, normally influenced by man. And along the top, I've used the terminology that's used to describe different trophic or nutrient levels. They range from dystrophic to oligotrophic at the nutrient-poor end to eutrophic and hypertrophic at the nutrient-rich end. And as there are increasing levels of nutrients in a water body, these are mirrored by an increasing abundance and density of plants, although the number of species associated with those water bodies may decrease as nutrient levels increase. So if we think about the nutrient-poor water bodies first, the nutrient-poor lakes and ponds, how might we identify these? Well, they tend to be characterised by clear water or water that is peaty or stained brown as a result of having run through peat. They're normally very clear, and so it's very easy to see the substrates, particularly at the edges of the lake. The water tends to be acid, slightly acid or neutral in terms of its pH, and they tend to be characterised by either peaty substrates or by lots of bare rock or areas of sand, as you can see in these example photographs. The vegetation tends to be fairly sparse or abundant, but it's very rarely lush. And the typical species that you might come across include bog bean, bog pondweed, quillwort, water lobelia and bladderworts. Just be aware that some sites, a very limited number of sites called marl sites or limestone lochs on lakes, have very clear water, but these are characterised by areas of high level of calcium carbonate, and they would have a large number of stonewort species in them and have a very limited distribution. But generally, if you're finding a rocky lake with very sparse vegetation and very clear water or brown stained, then that is most likely to be a nutrient poor water body. These maps give you a flavour of the distribution of nutrient poor water bodies throughout Britain. You can see that they tend to be grouped in the north and the west, in the areas where there are nutrient poor or acid rocks. So we get highlands in Wales, highlands in Scotland, north and west of Scotland. You're unlikely to encounter them down in the south and east of England. So turning now to the nutrient-rich water bodies, or as they're also known as mesotrophic, eutrophic or hypertrophic water bodies, these tend to be characterised more by green water. The water colour looks green because of the levels of suspended algae within it, and as a consequence it might be quite cloudy and difficult to see very far below the water surface. The pH tends to be neutral to alkaline. The main substrates of these water bodies tends to be silts and muds or soft substrates. The vegetation might be very lush, and there might be areas of algae covering bits of the surface. Typical species include pondweeds, water milfoils and yellow water lily. And here we have some examples of where you might encounter nutrient-rich sites, and you can see they occur more around the lowlands and northeast coast of Scotland and occur further down into England and the southeast. Now, although I've talked about some typical characteristics of nutrient-poor and nutrient-rich lakes and ponds, it can be difficult just looking at the water surface to tell what type of fine habitat you're looking at. So it might not be possible at the start of your survey to indicate on your recording form what type of fine habitat you're in. Also, depending on what level you're recording at in terms of species, it might still be tricky to tell which of the fine habitats you're looking at. That's because some of the species that would be most characteristic indicators of trophic level aren't included within the wildflower or the indicator level of survey, or are species of wet edges and hence might be indicators of the soil conditions around the lake rather than the lake itself. Or they might not be very easy to identify from a distance, or they might not be present within that 1 metre recording strip from the edge. For that reason, what I'd suggest is that rather than worrying about what type of fine habitat you have at the start of your survey, carry out your survey, look at the species that you've recorded, and then see whether these are most characteristic of a nutrient poor or a nutrient rich water body. Before we move on to consider some of the species that might be found in fresh waters, I wanted to talk about a few points of the recording scheme which are specific to fresh waters. The first thing is that fresh waters do not exist in a vacuum. They are always located associated with or within other habitats, such as woodland, wet woodland, grassland, marshes, fens, and peatlands. Because of that, some of the plants that you might find at the edge of the fresh waters are plants that are tolerant of waterlogged or damp conditions and are not what I would call a true aquatic or an obligate aquatic. That is, they don't necessarily need to be found in or associated with standing or running water. Because of that, I'm going to focus very much today on what I would call the true aquatics, that is, things that you will only find associated with standing or running waters. Some of the other damp-loving species, such as silverweed, teasel. The final thing I wanted to remind you of before we turn to look at the species themselves is the need to make sure that you don't inadvertently transfer plant material between different freshwater sites. Invasive species are one of the biggest threats to biodiversity, and there are a number of non-native invasive species that are currently causing harm to our water bodies here in Britain. These include species of invertebrate as well as plant species. Many aquatic plants are able, or indeed rely heavily upon, vegetative means for reproduction. Some species are able to regenerate from very small fragments of stem and leaf. That means it's very easy for a small fragment of plant material caught on your boot to be transferred between sites. I've seen evidence of this in the Highlands of Scotland, where sometimes very remote sites have been colonised by Canadian waterweed, and these tend to be the sites which are most popular with fishermen, and the most likely cause of the source of this introduction of the species has been as dried material caught up on fishing gear. There is good advice online as part of the national Check Clean Dry campaign of ways of preventing spread of material between sites. And I know NPMS are going to be sending out more information to people about the needs for biosecurity and preventing spread of species between sites. Okay, let's just have a quick refresher and reminder of what we've learned so far about the different fine habitats that you might encounter. Take a look at this photo and decide whether you think this is most likely to be an example of a nutrient-poor lake or a nutrient-rich lake. Yeah, the answer is a nutrient-rich lake. The clues that we're looking for here are dense beds of fringing vegetation and emergent growth, signs of lush vegetation, and a green water colour. And again, take a look at this photo. What type of fine habitat do we think is most likely to be present here? A nutrient-poor lake or a nutrient-rich lake? Yep, this is a nutrient-poor lake. The clues are sparse vegetation, clear water, and you can also take some clues from the habitat because this site is obviously set in the uplands and in a peatland area. Aquatic botanists tend to group water plants into categories depending upon their growth form or the habitat zone which you find them growing within in a water body. These habitat zones are most pronounced in nutrient-rich and nutrient-poor standing water sites, but are also visible in running waters. If we look at my little sketch here, we have the bank on the left-hand side and then increasing water depth as we move towards the right of the picture. Plant species which tend to grow right at the water's edge are known as marginal species. This includes several species which are tolerant of waterlogged conditions and are able to withstand short periods of inundation by water, but might not require to be next to a big pool of water. So that includes all the marsh and the fen species, which might be found in damp conditions, but aren't necessarily needing to be next to a standing water site or a river. Next, we have the emergent species. These tend to have their roots in areas which are permanently waterlogged or generally below the surface of the water level. But they may have leaves and stems and flowering parts which emerge above the water surface, and they can extend for some distance out from the shore. Next, we have submerged plants, and these require to be almost always permanently below the water surface. They include submerged rooted plants, which are fixed, and the extent within the water body to which submerged rooted plants extend depends on the point at which light can still penetrate the water surface. Then we have other submerged plants which aren't fixed at all, and they float around in the water body at the whim of currents and water flow. These submerged plants, whilst they might be rooted below the water surface, may have aerial parts or produce flower spikes which rise above the water surface. Then we have the floating species, and again these are subdivided into those which are rooted at the base here, and then they throw up floating leaves which sit on the surface and are joined by long leaf stems. And then we have some free-floating species which, like the free-floating submerged plants, drift around at the whim of currents. Okay, so we're just going to have a little quiz now. If you look at the slide, you can see that there are two different growth forms of vegetation which are labelled A, which are the tall green stems that you can see in the middle ground and slightly in the rear area of the photograph, and a second growth form marked B, which is shown in the foreground. Can you tell me which is floating vegetation, A or B, and which is the emergent vegetation, A or B? So hopefully that wasn't too tricky. The emergent vegetation is A. It's the tall stems which are emerging above the water surface, and the floating vegetation is the vegetation in the foreground which has floating leaves on the surface. One of the things that can often put people off recording water plants is the fact that very rarely do they have any flowers. That means that you need to be able to distinguish species mainly on their vegetative characteristics. Not only that, sometimes unrelated species can look superficially very similar in response to the growing conditions in which they are found. There are a large number of water plant species potentially that you might encounter during your survey, but if you're recording at the wildflower or the inventory level, you only need to be familiar with a few of those. However, these might be very similar superficially to species which you don't need to record. So part of the trick is going to be for you to get your eye in and for you to be able to distinguish between different sorts of very similar looking species and work out which ones you need to record and which ones you don't. So for a bit of fun, I've just included this photo here to see if you can start to get your eye in and start to distinguish whether it's all the same green spiky thing or whether there are different sorts of green spiky thing within the photo. And actually, if you have a look, you can see that some things, there are some different plants, and I've not marked them all, but what we're looking at is the colour of green, for example, how flat the leaf is, how they're arranged on the stem, whether or not they've got a midrib, and we'll be looking at the tips of the leaves as well. I'm hoping today's session will give you some confidence in identifying water plants, but you may find when you're out and about that you want to take some guides or books with you to provide further advice. I've provided a list of suitable sources at the end of the presentation, but I wanted to flag up these two books here as they have both helped to inform some of the information that I'm now going to present to you. On the left is the recently republished Field Studies Council Guide to British Water Plants. This contains a whole series of keys which were first written back in 1975. It was the first book that I used to get into water plants, and I still go back to it today because it's really helpful in grouping plants by habitat, by leaf form, by growth form, and helps to give you a clue as to what you might be muddling different species up with. The book on the right is designed for those of you who like nice colour, glossy photos, and again it's at quite a superficial level but does provide some nice illustrations to help confirm your identification skills. Okay, we're going to move now to consider some of the species that you might find during your survey. I'm going to talk about these dependent on the growth form of the plants. So I'm going to start off considering the submerged species that you might find. Then I'm going to talk about floating species. And finally, I'm going to talk about marginal and emergent species. As I've explained, it can be tricky to identify which fine habitat you're looking at when you arrive at the bank of a water body, and sometimes unrelated species can look superficially similar. So for those reasons, I think it's much easier to consider plants based on their growth form, and then at the end of the session we'll go back and look at which species are associated with each fine habitat type. I estimate that there are probably around 200 different full species or hybrids of submerged plants in the UK. But the number of species that you need to record at the wildflower or the indicator level is much reduced. And you're also going to be limited in terms of the number of species you encounter by the fact that you're only recording out to a metre from the bank. And that means it's probably you're going to be recording in quite shallow water where not all of the species that would be characteristic of each fine habitat might occur. So during the session, I'm going to be concentrating upon those species that might occur near the edges and which are listed either in the wildflower or the indicator lists on the NPMS recording form. To help with the process, I've drawn up a series of little keys like this one here for each group of growth form of plants. So we've got one for submerged plants, there'll be one for floating and several for the emergent plants. And this will help you hopefully in identifying those species that you need to record during the survey. These keys have been drawn up specifically for the NPMS, so just be aware that there are other species that aren't identified here that you might possibly encounter during your survey. So looking at the submerged plants, I've grouped them into 4 broad categories. We've got those which have a rosette growth form, those which comprise broad leaves along a stem, those which have strap-like leaves in whorls arranged around the stem, and finally divided leaves. And we're now going to move on to consider each of these. The first category of submerged plant we're going to look at are the rosettes. And here we have a perfect example of unrelated species looking superficially similar to each other. On the left, we have shoreweed, Littorella uniflora. And on the right, we have water lobelia, Lobelia dortmana. And these are just 2 of perhaps 5 or 6 different rosette species that occur in British waters. How do we tell them apart? Well, Littorella here, this shows us the typical growth form. It grows right on the very margins of water bodies. You can find it in rivers and lakes as well as nutrient-rich and actually nutrient-poor habitats. And it tends to span the area where there can be seasonal drawdown. It's able to survive periods of exposure to the air if there's a drawdown in water level. It consists of a few rounded green stems with sort of rounded pointed tips here, white roots, but it's often characterized by runners, which helps to form these dense mats of vegetation. Colour-wise, it's quite variable. You can get this sort of pale yellowy green here, but I have seen it in very nutrient-rich conditions, turning almost a deep dark green, bottle green in colour. The leaves are stiff, and you can see from this plant, which I've pulled out of the water, it retains its shape, and the leaves are sort of all pointing upwards or horizontally. The cross-section of the leaf tends to be rounded, and the sides of the leaves tend to be parallel-sided. And if you took a leaf between your thumb and forefinger and compressed it, you'd find it be slightly spongy, reminiscent of a soft brush. By contrast, if we look on the right, we have our water lobelia, and this also grows in a rosette, but the plants tend to be more individual rather than linked by runners. The leaves are parallel-sided, but they are rounded at the tips, and they can often be slightly recurved. The leaf is broader and flattened compared to the Littorella leaf. And if you were to snap one of these leaves off, if you snapped it across here and looked down at the cross section, you would see 2 parallel hollow tubes. Like the Littorella, it's quite a stiff plant, so if you pulled a plant out of the water, you would find that the leaves would retain their shape and the leaves might be slightly recurved. If you are lucky enough in sort of early summer, you may find the flowering spikes of lobelia which rise up above the water surface and have a small purple flower sitting well above the water surface, and that's quite characteristic, and you might see that from a distance as you walk towards your plant. Now at the bottom of each slide I've included details of other species that you might potentially confuse these plants with. Isoetes I'm going to cover on the next slide. Subularia aquatica, which is all wort, has quite a restricted distribution and has slightly channeled leaves, so you're less likely to muddle that with either of these species because the leaf surface has a slight channel along it. Eriocorlon has a very restricted distribution and is only found in 1 or 2 locations in Argyll and in Skye. So if you're surveying in those areas, just be aware that you might come across that species. Water plantains generally, when they're fully grown, are very different to these rosette species, but the young plants can have some strap-like leaves, but they usually have floating leaves as well, so very easy to tell apart. But the main species you might muddle these two species, the Littorella and the lobelia, with is Isoetes, which I'm going to cover on the next slide. This slide shows some pictures of Isoetes lacustris, which is one of the other rosette growth forms that you might encounter during your surveys. It tends to grow in deeper water than either Littorella or lobelia, but you may find plants washed up along the shoreline, as in the example on the left-hand side of the slide. If you do find this plant, then it's a very good indicator of a nutrient-poor lake. Ways that you can tell this apart from other rosette species are by the little white cross walls on the leaves, which you can see very well in the right-hand picture. They're the little white flecks that you can see. To me, they're always very reminiscent of white flecks on a fingernail. It's a rooted plant, but unlike Littorella, it doesn't have a series of runners, so it'll be an individual plant. Again, if we look at the leaf, and if you extract a leaf from the base of the rosette, you'll see that the leaf as it joins the rosette tends to be slightly expanded and flattened, and to me it's very reminiscent of a stick of celery, the way that a stick of celery grows from the bottom. And in that little bottom area, you will sometimes find tiny little sphericals, which almost like grains of sand. And these are the spores of Isoetes because it's a member of the fern family. Other things to look at are the general growth form. The leaves are slightly recurved, but not as much as lobelia. And again, if you snap the leaf stem, you won't see 2 parallel tubes, which are characteristic of lobelia. The tips are slightly pointed like Isoetes, but as I've said, it doesn't have runners, and the texture of Isoetes tends to be much more crunchy and crispy, more reminiscent of celery than Littorella, which is very spongy when you press it. There is 1 or 2 other species of Isoetes that you might encounter, but you can again distinguish the Isoetes from the Littorella and lobelia, particularly by the presence of these white cross walls and by the presence of the little spores in the base of the leaf. We move now to those which have got broad leaves along a stem. There are only 2 species that you need to be able to recognise for the wildflower and the indicator level of recording, and these are both species of pondweed. The pondweeds, or Potamogeton, are one of the largest genus of freshwater plants in the UK. There are in excess of 40 different species and recognised hybrids. In fact, this group is very good at hybridizing, and some of the hybrids are fertile, and you can find the hybrids in sites even where you don't have either parent. They exhibit great variation in morphology depending on the depth of water at which you find the species and depending upon nutrient levels, so they can be quite variable. As I say, you only need to be able to recognise these 2 species, and they are perhaps 2 of the easiest pondweed species to be able to identify. So the first point to note is that all pondweeds have their leaves arranged alternately along the stem, and that's illustrated very nicely in both these pictures here. The species on the left is called curled pondweed or Potamogeton crispus. And when you find it in its typical form, as I've photographed here, it is quite characteristic in having this very wavy or crispy appearing edge. And the edge of the leaves have little minute teeth, which you can see just about with the naked eye, but certainly with a hand lens. In some conditions, the leaves aren't as curly or as crispy as that. In fact, towards the nutrient poor end of its range, you quite often find that the leaves are completely flat, but they will retain this sort of oblong shape and they will always have minute teeth. So it's always worth just checking with your hand lens whether or not there are teeth present. Species on the right is Potamogeton perfoliatus or perfoliate pondweed, and perfoliate, if you're not familiar with the term, means that the leaf base almost completely encircles or encapsulates the stem, as you can see on this picture here. The leaves again are quite variable, but the very characteristic element I think of this species are these sort of white, the very clear appearance of the veins, which from a distance make it look almost like a zebra plant. Here they're quite dark green veins, but you can find examples where the veins look quite white, and so it's a very stark contrast between green and white veins, making it look very much, I think, like a little zebra. When this plant is young, you might find minute teeth around the leaf, but it's very, very different, as you can see, from Potamogeton crispus. Crispus doesn't have this perfoliate base to the leaf. There are many, many other species of pondweed, but they are unlikely to be mistaken with these two. There are narrow-leafed grass-leaf pondweeds and other broadleaf species. The only one that you might get vaguely confused with is Potamogeton prylongus, which, like the perfoliatus, can have these long leaves and sometimes a slight appearance of paler or darker veins. The main difference being that prylongus has a very hooded tip, and you can tell that if you take a leaf between your thumb and forefinger and run them either side of the leaf to flatten it, the tip will snap open to sort of form two little points. Because it's hooded and it's gone round a corner, and you're straightening that out and flattening it, which the perfoliatus very rarely has. Neither of these species have any floating leaves, so if you come across plants which look superficially like this but have floating leaves, then you've probably found one of the hybrids rather than the pure species. If you get very interested in your pondweeds and want to know more or identify other species, then BSBI. We're going to move on now to consider some of those submerged plants which have strap-like leaves arranged in whorls around a stem. The photos show two different species of waterweed, or Elodea species. On the left we have Canadian waterweed, and on the right Nuttall's waterweed. You don't need to worry too much which species you find during your survey. It's sufficient just to record Elodea species. These are introduced species, non-native species within Britain, and an example of a species that can cause problems for our native flora. Once they get into a site, they can show booms in growth and start to outcompete our native species. And they're some of the many species that we need to thank the Victorians for bringing to our waterways. Although virtually all the plants that have been recorded in Britain are female, they are able to spread themselves very successfully using vegetative means. And they're an example of the species I was talking about earlier, that it's very easy to transfer between sites as fragments of material caught on boots or fishing gear. So just a note of caution there, and be careful that you don't take any bits away with you from sites that you're surveying. If we look at how we would go about identifying these, the key thing to look at is the arrangement of the leaves in their whorls on the stem. And the leaves are arranged in groups of 3. And that's easiest to see in the picture on the right. So we can see a length of stem, 3 leaves around the stem, another length of stem, and 3 leaves in a whorl around the stem. There is some variation in leaf width, as you can see between the two pictures, but generally the leaves are relatively strap-like, thin, translucent green. In Canadian waterweed, they tend to be slightly recurved, as you can see on the left, and in Nuttall's waterweed, you can see that they're slightly twisted. The things that you're most likely to muddle the waterweeds with are other introduced species of waterweed, and we'll look at the next slide to talk about some of those. So we're going to consider now which species you could potentially muddle Canadian and Nuttall's waterweed with. And the main species that look similar are some other species of introduced waterweed or non-native species in Britain. And illustrated here is Lagarosiphon major, curly pondweed, which does look quite superficially similar, particularly to the Canadian waterweed. But the main distinction between the two is that Lagarosiphon has its leaves arranged in a spiral up the stem rather than in the whorls of three that we saw on the previous slide. I've listed in the box at the bottom, there's also another species of waterweed which looks similar, Egeria densa, known as large flowered or Brazilian pondweed waterweed. This has its leaves in whorls of 4 or 5 instead of 3, and that's how you would separate it out from Elodea. This tends to have a very limited distribution, Egeria, and is normally associated with some canal sites down in England, which is probably how that species was introduced. There are some native species that you could potentially get slightly muddled with, and the first group are the water starworts, the Calitrichae, because these also have strap-like leaves, which are often very translucent. But their main distinction from the Elodea is that they are in pairs, arranged in pairs up the stem, compared to these whorls of 3 that we see with the Elodea. Also, the Calitrichae tend to have little tiny notches in the ends of the leaves, and in one species, in fact, these notches are so pronounced that the ends of the leaves look little like spanners, like little miniature spanners hanging on the stem. Hippurus vulgaris is a species mare's tail that we're going to talk about a few times during the presentation, and it has submerged leaves arranged in a whorl around the stem, which again are very pale green and translucent, but these occur in whorls typically of 8, can vary between 6 and 12, but typically 8 around the stem. And the final species to be aware of as a potential to confuse with the waterweeds is the slender naiad, Nias flexilis. This is a very rare plant. In fact, it's protected under Schedule 8 of the Wildlife and Countryside Act. So if you do come across it, please don't touch it, as you're not allowed to pick it or disturb it under the provisions of the Act. It has a very limited distribution, and you're only likely to encounter it if you're working in Argyll, in Perthshire, in the islands of Scotland or the west coast of Ireland. And I think there's been a couple of records from the Lake District. They're arranged, the leaves for slender naiad are arranged in pairs as well as whorls of 3 and 4. So it is quite distinct from Elodea. If you get to see it, I think you'll spot it straight away. Now, I just mentioned mare's tail, Hippurus vulgaris, as a native species, that there could be possible confusion between this and the Elodea species. As I've said, the Elodea has leaves in whorls of 3, whereas Hippurus tends to have leaves in whorls of between 6 and 12 around the stem. It's quite tricky to get photos of this in its submerged form, and this photo is actually the emergent form, and we'll be coming back to this species when we talk about emergent species later in the presentation. But it's unusual to just find the submerged stem. So if you look at this is the Hippurus. If you pulled this stem up, you would find below the water surface that these leaves become soft and flaccid, but are still grouped in sort of whorls of 6 to 12 around the stem. Our final category of submerged plant are those which have finely divided leaves. There are several species of native submerged plant which have finely divided leaves, but the main species that you need to look out for is a non-native or invasive species called Myriophyllum aquaticum, or parrot's feather, which is shown on the left here. Parrot's feather has submerged stems, but it's almost always characterized by also having these emergent stems, and they would be the feature that I would mainly look for. So it looks like each leaflet looks like a little feather, and they're joined in whorls of usually 5 around the stem. Occasionally it might be 4 or 6, but usually there are 5 of these little feather-like leaves arranged around the stem. It always tends to be this very bright, almost acid green colour, which is very noticeable when you see it in the wild, and often forms very dense clumps, as in this picture here. You could conceivably muddle it up with our native species of water milfoil. Myriophyllum alterniflorum and Myriophyllum spicatum are the most common native species. And the picture on the right shows some Myriophyllum alterniflorum, which I've taken out of a water body. That again has feather-like leaves arranged around a stem, but they tend to be in whorls of 3 or 4, very rarely 5 or 6, as is the case with the parrot's feather. The native water milfoils tend to be more reddish in colour, having reddish stems, reddish leaves, and they never form emergent stems above the water surface. You might see the flowers above the water surface, but you won't see this dense growth of emergent stems above the water with the native species. Other things potentially you might muddle it with would be the mare's tail that we just looked at, but that looks more like little Christmas trees, and as we've said, it tends to have leaves in sort of 8 to 12 around the stem rather than in these whorls of 5. Water violet, Houtonia palustris, which has a different leaf shape, and we'll talk about that. Houtonia palustris water violet has leaves which look more like herringbones rather than feathers, and the leaves are very clearly flattened, and they're not arranged in whorls around the stem, but they tend to be alternate up the stem. So that's the difference between water violet and parrot's feather, is whether or not they're arranged in whorls or alternate up the stem. And the other main divided species that you're going to come across, particularly in standing waters, would be the hornworts, Keratophyllum demersum and submersum. These don't have emergent stems, they won't survive on mud, and they usually have 6 to 8 leaves in a whorl around the stem, and they don't look like feathers. Instead, each leaf divides into 2 segments, more like a tuning fork, and I've got a picture to illustrate that in a minute. So each segment may keep forking, so it looks like lots of little miniature tuning forks joined onto each other, rather than like a feather or a herringbone. The other group of species which have finely divided leaves are the ranunculus, or water crowfoot. These are most commonly associated with rivers and streams, but you can find species in standing waters too. They are characterised by big beds of long, finely divided leaves and stems, which can form very dense beds that swing and sway in the stream. And the density of vegetation can be such that it can actually alter the flow and create riffles within the watercourse. When they're in flower, they are completely unmistakable. They tend to flower having little buttercup-style flowers which are white rather than yellow. Occasionally, some of the species may develop floating leaves, particularly when water levels start to drop. The submerged leaves are forked and very, very soft and floppy. I've shown on the right another species of ranunculus, which really is a marginal or emergent species rather than a submerged species. This is known as Ranunculus sceleratus, or celery leaf buttercup. It's not the best picture in the world, and I apologise for that. It was quite tricky to find a decent picture at all, This has little buttercup style flowers and leaves which, as the name suggests, look like celery. The water crowfoots, which you find in water, as I say, are normally fairly characteristic, but there is a vague chance that you might muddle them up with the species that I've listed in the box below. And on the next slide, I'm going to talk about how the leaf shapes vary between these different species to help you make the distinctions. I've drawn a little sketch to try and help illustrate some of the different style of leaves that might be found on submerged plants which have finely divided leaves. So the ranunculus that we've just been talking about here have very long, very flaccid leaves which are divided first of all into three before they can then end up forking. And that is the only species where the leaves start off by dividing into three, so that's very characteristic. Keratophyllum, which we've talked about as something which has leaves around in whorls around the stem, has forks at the end, like little tuning forks here, but are different to the ranunculus in that they're found in the whorls around the stem. We've mentioned apium as something that might get confused with either the ranunculus or myriophyllum, but the main difference here is that the leaf is pinnate. And by pinnate, we mean we have a central stem with small leaves arranged either side of it. And these are very different to the leaves of myriophyllum, which are found in whorls around the stem where the leaves tend to look like little feathers. Before we move on to considering some of the floating leaf species that you might encounter, I've put in 4 photos of submerged plants that we've just talked about. And here's your chance to see if you can recall the characteristics of these different species. So what is species A? What is species B? What is species C? And what is species D? And the answers are A is shoreweed, Litorella uniflora. We've got these long, almost parallel-sided, spongy green leaves with slightly pointed tips and runners. B is curled pondweed, Potamogeton crispus, with these very characteristic wavy edges to the oblong-shaped leaves with teeth. C is water lobelia, Lobelia dortmana, which is also a rosette species but has slightly recurved, blunt-ended leaves, which if we snapped would have parallel tubes. And species D are ranunculus, water crowfoot, which are characterised by long stems and leaves flowing in running waters. We're going to move on now to considering the floating leaved species. And as I said earlier, floating leaf species can either be rooted or free floating. Those which are rooted tend to be limited to the area where their stems or leaves can stretch to the water surface, and therefore they need to be in a depth which would allow that to happen. Free floating species get blown around or drifted around depending upon current and wind. Some species float on the water surface, whereas others float within the water column. Those which you find on the water surface tend to have a very waxy upper surface, which acts as waterproofing. Again, I've drawn up a little key that hopefully will help you work out those species that you need to record for WF or indicator level recording. So the first thing to look at is whether the plant is free floating on the water surface, whether it's free floating below the water surface, and whether or not it's rooted. For those which are floating on the water surface, you need to look at the shape of the leaf outline. Is it either a smooth, rounded leaf, in which case it might be one of the duckweeds, or frogbit, Lemna, Spirodella, or Hydrocharis? Does it have a crinkly or a wavy edge, in which case it might be the water fern, Azolla? Only one species floats freely below the water surface, and that's one of the duckweeds, Lemna trisulca. And then we've got 3 species which are rooted, which have leaves floating on the water surface. And these are the water lilies, the yellow and white water lily, Nuphar lutea, Nymphea alba, and also the amphibious bistalk, Persicaria amphibia. So looking at those plants which are free floating on the water surface and which have a rounded leaf outline, we've got different species of duckweed. On the left we have Lemna gibber, fat duckweed, and on the right we have Spirodella polyrhiza, greater duckweed. There are lots of species of duckweed, or several species of duckweed, so there can be difficulties in separating out some of these species. In general terms, the duckweeds, you'll recognise them because they tend to have single fronds or 2 fronds joined together, as we've got on the right here, that float on the water surface. They tend to have tiny roots from their underside, but as they're not fixed to the substrate, they tend to drift around depending on current and wind directions. Lemna gibber on the left has very small green oval fronds, which don't tend to be more than about 2 millimeters across. But the main defining feature is that rather than being a flat leaf sitting on the surface, they tend to be fat and have a little sort of bulge below the water surface. This is the key characteristic that distinguishes it from Lemna minor and Lemna minuta, the other 2 species of duckweed that you will commonly find on ponds. The tricky element is that this species, Lemna gibber, doesn't always exhibit this fat shape, and when it doesn't exhibit this fat shape, you won't be able to tell it from the other species of duckweed. Spirodella on the right, by contrast, is our biggest duckweed, and the leaflets or thallus are normally about 5 millimeters across, and in fact they can extend up to 10 millimeters, so they can get quite large. They might be slightly purplish underneath if you lift up the frond, and they tend to have several roots hanging from a single point underneath the leaf, as you can see in the picture. And the things that you're most likely to muddle these up with are other species of duckweed, as I've just said, and a zolla, which is water fern, which we'll talk about shortly. There is another species that has small roughly oval shaped leaves that float on the water surface, which are just a little bit bigger than the duckweeds, that you might model either for duckweed or potentially for water lilies, and that's the frogbit, Hydrocharis morsus rani. The main difference between this and the water lilies is that Hydrocharis isn't rooted, so it's free to drift around. You'll mainly find the species in the southern part of Britain. The leaves are almost circular, and they're 1 to 3 centimetres wide compared to the sort of 5 millimetres or less that we were talking about for the duckweeds. It does tend to look rather like a miniature water lily, but there's very characteristic sort of 2 horseshoe shape. The veins form horseshoe shapes. The plant comprises 3 to 5 leaves which are joined just below the water surface in a rosette, and the different plants can be joined together by runners. And as you can see in this picture, they can have flowers, white flowers with 3 petals. The main thing, as I say, you might muddle this with are the water lilies, particularly fringed water lily, but the key characteristic here is the venation of the 2 little horseshoe shapes, the entire edge to the leaf, and also the fact that this species isn't rooted. Moving now to another free-floating plant, but this one has a crinkled edge rather than an entire edge. We have water fern, or Zolla folliculoides. It's a fern, and the characteristic feature are these little crinkled edges, and it often goes a very sort of bright red colour, often in the winter or when it gets frosted. Has small branching stems covered with scale-like overlapping leaves, and in some water bodies it can form a really dense surface covering. The only thing you could conceivably confuse this with would be the duckweeds that we've already talked about, but the key differences are the red colour and the fact that the leaf edges are crinkly rather than entire. Moving now to those species which are free floating but below the water surface, the only species really is ivy leaf duckweed, Lemna trisulca. And this is probably the easiest of all the duckweeds to identify. As its name suggests, the leaves look like miniature ivy leaves, but actually I think when you look at them it looks more like a string of bunting that's all being tied and tangled up together. It floats just below the water surface rather than on top of it, and can sometimes fall quite dense balls or strands where the fronds all get interlocked together. And I think when you look at this, it shows, it sort of looks like sometimes like quite bright green, almost tennis balls floating below the water surface. The leaves are very thin and translucent, and they have tiny little roots coming from each one. But it's a very characteristic species, and I don't think that you'll have any difficulty either in identifying it or distinguishing it from any other species that you might encounter. We're going to move on now from considering those plants that are free floating to those plants which are rooted but which have floating leaves rising up to the water surface. The species we're perhaps most familiar with are the water lilies. On the slide on the left we have yellow water lily, Nuphar lutea, and on the right we have white water lily, Nymphaea alba. And when they're in flower, as you can see, they're very easy to tell apart. But once you know what features to look for, they're also quite easy to tell apart even if you haven't got any flowers. The features you need to look out for are the shape of the leaf, the colour of the leaf, the shape of the leaf stalk, and the pattern of the venation on the underside of the leaf. And we'll talk a little bit about that on the next slide. So if we start on the left with the yellow water lily, we can see that the leaves are oval, more oval in shape. They tend to be very bright green or yellow-green in colour. The leaf stalk in cross-section is oval, and it's also the only species of water lily that you'll come across which has submerged leaves. And these look very different to the floating leaves. They're very thin, pale green, translucent, and I always think they look rather like a Webb's lettuce stuck on the bottom of a lake or a river with these tall floating leaves coming out from the base of them. If we turn to the right now and look at the white water lily, we can see that the leaves are more rounded in outline or almost heart-shaped on occasions. They tend to be a much darker green, and sometimes you get slight reddish or burgundy tinge to the coloration, particularly on the underside of the leaf. It doesn't have any submerged leaves, and if you were to take a cross-section of the leaf stalk, you would see that it was rounded in cross-section. The main potential to confuse either of these species would be with other species of water lily. So in terms of the yellow water lily, there is another native species of yellow water lily called Nuphar pumila, which tends to have similar leaves but much smaller, and the flowers tend to be smaller. And the way that you tell the two species apart is dependent upon the number of ray florets in the flower and fruit. Nuphar pumila tends to have a much more restricted distribution. You might come across it particularly in northern Scotland, down into Perthshire and in Shropshire, and the Nuphar lutea and Nuphar pumila hybridise. But unless you're operating in bits of Scotland or Shropshire, you probably won't come across Nuphar pumila or its hybrid. In terms of white water lily, just be aware that quite often a lot of garden variants are Nymphaea alba species but have been bred for garden ponds with different flower colours, so sometimes you can come across those as garden escapes. There's a third type of water lily that you also might encounter called Nymphoides peltata, and that tends to be much smaller, and the leaves are entire but have a very sort of crinkly toothed edge. And we'll see a little bit more about those on the next slide. So if you flip a leaf over and look at the rear of a leaf, you'll get these different venation patterns. And on the left, we've got Nuphar lutea, and this you have a central vein up the centre, and then you have these forking veins coming off that central stem, which fork out to hit the edge of the leaf. With Nymphaea alba, when you turn it over, you've got this central stem again, but you also have veins fanning out from that, and in between you've got these cross-connecting veins which form a honeycomb effect over the whole of the surface of the leaf on the rear. Nymphoides peltata tends to be a smaller, rounder leaf, but it has a very obvious, pronounced, crinkly, wavy edge. The Nuphar lutea, if you look at the leaf stem, it tends to be oval in cross-section, whereas the leaf stem of Nymphaea alba tends to have a round, more solid stalk, and the Nymphoides peltata also has a round stalk, but it also tends to have spots on the underside of the leaf. So they're really quite easy to tell apart if you look at the leaf. The final species that's rooted but has floating leaves that we're going to consider is Persicaria amphibia, the amphibious bistort, which is shown in the photograph on the left. This is another species that's undergone a name change, and if you look in older books you might see it called Polygonum amphibian. It has these oval, almost oblong, dark green leaves. It's very characteristic once it's flowering because it has a pink flower spike rising above the water surface, which looks very similar to the flower spike of redshank and terrestrial persicarias, or the garden Persicaria polygonum that you might be familiar with. This red theme is continued in the stems because often the stems are quite reddish as well. And it can form very dense mats on the surface of water bodies, particularly on reservoirs or very still water. You can find quite dense mats. There is another species shown on the right, Potamogeton natans, floating pondweed, which can also have a similar growth form in forming these dense mats on the surface. And the main ways to tell them apart are in leaf shape. So the polygonum, as I say, has this, the Persicaria has this long oblong leaf shape, whereas the pondweed on the right has a more oval leaf shape. The veins on the Persicaria come out from the central midrib at approximately right angles to the midrib and extend to the edge of the leaf, whereas in the Potamogeton on the right, the veins are parallel-sided, all coming from the base of the leaf in parallel, roughly parallel, and then meeting together again at the apex of the leaf. The Potamogeton also has a little sort of what's called a hinge at the base of the leaf. So if you picked up a leaf stem, you would find that the leaf has a little kink, leaf stem has a little kink just before it meets the leaf, and that's how you tell the two species apart. So a little refresher to see what you can remember from the floating leaved species. Can you identify species A, species B, species C, and species D? So A was the yellow water lily, Nuphar lutea. It's got oval leaves and a light green colour. And if we flipped it over on the rear, we would see veins which come out from a central stem and fork towards the edge of the leaf. Species B was the ivy-leaved duckweed, Lemna trisulca, which is this bright green, translucent, triangular little leaves joined together by stems, rather reminiscent of bunting. C is white water lily, Nymphaea alba, characterised by almost circular leaves, which if we flipped over would have a honeycomb arrangement of veins on the back and would have a round leaf stem. And D is the amphibious bistort, Persicaria amphibia, which has these oval to oblong dark green leaves with veins coming off the central vein at right angles. We're going to move on now to our final growth form category, which is that of the emergent and marginal species. As I've already said, it can be quite tricky sometimes to try and distinguish these tall, many different tall green spiky things which are growing along the edges of watercourses. This is a photograph of a canal reserve in the Midlands that I've worked on for a number of years, and there are several different species illustrated in the picture. We've got some sedges on the left, we've got some branched burreed on the right, we've also got some typha, some bulrush. So there's at least 3 or 4 different species that I can pick out from the photograph. So part of the trick is going to be for you to get your eyes in, and I'm hoping that some of the following tips will help you to distinguish between these tall emergent green plants. Ways of telling the different emergents apart then, looking at our little key. We're going to start first of all looking at those emergent species which either don't have any or very narrow linear leaves. And within that group we've got those which have got narrow leaves in whorls around the stem. And there are 2 species we're going to look at: Hippurus, mare's tail, which we've already talked about, and water horsetail. We've got those emergents which don't have any leaves on the stem, and we're going to talk about Chenoplectus lacustris and spikerush Eleochris multicornis. We've got plants which have got a triangular cross-section, triangular leaves, where we're going to be talking about 3 species: Sparganium, burreed, sedges, carex, and flowering rush, butamus. We're going to talk about those emergents which have got flattened leaves all coming from the base, and we're going to talk about iris and bulrush, typha, and then we're going to talk about those emergents which have got alternate leaves up the stem, which also sort of sheath the stem, and we're going to talk about Glyceria maxima. So quite a big grouping of these emergent plants which either don't have any or very narrow linear leaves. So thinking about those emergents where their leaves are arranged in whorls around the stem. If the leaves are in whorls of 8 or something between 6 and 12 around the stem, we're looking at mare's tail, which we've already talked about when we talked about the submerged plants in relation to water milfoil. Or the leaves might be arranged in whorls around the stem, but the stem itself is in sections that can easily be pulled apart. And if that's the case, then the stem can either be hollow and easy to flatten with very few branches, in which case it's likely to be water horsetail, or the stem might be quite solid with lots of branches, and in which case it's most likely to be marsh horsetail, Equisetum palustri. So just to recap, mare's tail, we've seen this picture before and we've talked about this before. It has a submerged part of soft, floppy leaves arranged in whorls of 6 to 12, but usually 8 leaflets around the stem. But the emergent part of this plant, to me, always looks like little miniature Christmas trees, and is quite characteristic from that point of view. You've got these quite stiff green leaves arranged in these whorls of about 8 around the stem, like little miniature Christmas trees. The other emergent species which can have narrow leaves in whorls around an emergent green stem are the water horsetails, or Equisetum family. There are 2 species that you are most likely to encounter during your surveys: marsh horsetail, Equisetum palustri, and water horsetail, which is the species you're mainly interested in, Equisetum fluviatile. These plants look superficially similar again in that they tend to comprise upright green stems, but the stem is subdivided into little sections which are marked by darker and lighter bands, and you can see that particularly in the picture on the left, where if you look at the right of that picture you can see that the sort of dark bands are up the green stem. So the stem is actually constructed of different sections which, if you took the stem and pulled gently, you could break apart at these points where the rings are, and what you're left with, as you can see in the picture on the right, is a little jaggedy edge which looks rather like a crown on the top of the broken bit of stem. If we look at the middle picture, the plant on the left is Equisetum palustre, and that's got lots and lots of branches in the whorls around the stem coming out at these points where you've got the little crowns. And if you looked at the cross section of a stem, there'd be a very narrow, hollow area up the centre of the stem. But if you try and compress the stem, you find it very hard, very solid. By contrast, the water horsetail on the right, has very, very few branches, and when you pull it apart and you look at the cross section, you see that the tube is almost completely hollow, and that means it's very easy to compress the stem with your fingers. Okay, now we're going to think about those species which don't have any leaves above the water surface, just an upright green unbranched stem. And we can split these depending upon whether the stems are very robust. They might be over 1 metre tall, more than 1 centimetre thick, dark green or green-grey in colour, very spongy stem centre, and they're growing usually in at least 1/2 metre of water. Or those which are narrower than that, they're less than 1/2 centimetre thick, and they're normally growing in water less than 1/2 metre deep. So if we look at the very robust species first, we're looking probably at a single species, Schenoplectus lacustris. Those which have got narrower stems, less than 1/2 centimetre thick and in the shallower water, we need to look at whether the tip of the stem is blunt or forms a terminal flower, and whether there's a sheath at the base of the stem, or whether the tip of the stem is very pointy and whether there are flowers on the side of the stem, and that will help us distinguish the different species. Let's look in more detail now at some of the species that have bare green stems emerging above the water surface. On the left we have a picture of Schenoplectus lacustris, or common clubrush. This is a species that has changed its name several times during my working lifetime, and you might see it called Scirpus lacustris in older books. It's a very robust, tall plant. It can grow up to 3 metres in height in up to about 1/2 metre water depth. So you might find that it's occurring offshore outside the extent of your survey area. It has very thick stems. They can be around about 1 centimetre thick at the base. And the stem itself is sort of a dark green, and it's quite spongy if you manage to pick it up to squash it. You might find it with brown flowers at the top. There is a similar related species called Schenoplectus tabernamontanii, which tends to be much more grey-green in colour and a little bit shorter, and it's much less robust. The stems are only up to about 0.8 millimetres across. There's also a third brackish species, but you shouldn't be encountering that if you've managed to maintain your survey in freshwater conditions. Because it is such a big, robust plant, it would be quite tricky to mistake this for any other species of emergent plant. On the right, we have the spike rushes, the Eleochorus species. And there are 2 species that you're most likely to encounter in the shallow edges of lakes. Eleochorus multicornis, the many-stalk spike rush, is the species that you need to record for wildflower indicator level. And Eleochorus palustris, the common spike rush, you would only record if you're doing inventory level recording. Unfortunately, I couldn't find a picture of Eleochorus multicornis, so the photos are of Eleochorus palustris, but they do look very similar, so this should be enough to help you at least recognise Eleochorus once you see it in the field. Eleochorus multicornis tends to be a little bit less robust than Eleochorus palustris, but I appreciate that's no use to you if you've not seen either species. You can see that it's growing here in amongst Equisetum, which is fairly typical, and it's a similar height to Equisetum, so Eleochorus multicornis will perhaps grow to about 20-30 centimetres, maybe a little bit more in height. The main way to tell the species apart is by looking at the sheath at the base of the spikes. So if you pick up a stem, as you can see growing loosely in amongst the Eleochris on the left, if you pulled one of those stems up from the base and have a look, you will see that there is a membranous sheath, and that's shown in the picture on the top right hand side, and the shape of that sheath is characteristic between the species. So in Eleochris palustris, as illustrated, the profile at the top of that sheath is more rounded. But in Eleochris multicornis, it rises up to a point. And for those of you who are old enough to remember osmeroid pen nibs from school days, the shape of the sheath is very reminiscent of an osmeroid pen nib. The Eleochrises, you're unlikely to mistake them with many other species, other than perhaps the rushes, the juncus, and particularly soft rush, Juncus effusus. Main difference here is that Juncus effusus tends to form quite dense tufts and be on drier land. You'll very rarely find it with its feet actually in the margins of a lake or a river. And the flowers of Juncus come out the side of the stem, whereas in Eleochris, as you can see in the picture on the left, there's a little flower spike at the top of the stem. Looks almost a bit like a grey wick on top of the green flower stem. Moving on now to those emergent species where the leaves or the stems are triangular in cross section, we need to look a little bit more at the arrangement of the leaves. So some plants have their leaves in two ranks. That means they're sort of almost divided symmetrically into two groups of leaves coming off the plant, and the leaves are normally more than a centimetre wide, and those leaves are triangular for most of their length. Then that's most likely to be Sparganium erectum. If the leaves are channeled, tapered to very fine points, the plant looks grass-like, it might be rough to touch, then it's most likely to be a Carex species, a species of sedge. And if the leaves are very narrow, less than 1 centimetre wide, perhaps slightly twisted with pointed tips, it's most likely to be flowering rush, Butamus umbellatus. If the plants have flowers, it's very easy to tell these different species apart, but I'm going to be talking also about vegetative characteristics in case there aren't any flowers. Okay, so we're now going to look at some of these species which have leaves or stems that are triangular in cross section in a bit more detail. On the left we have Sparganium erectum, which is the branched burreed. There are actually 4 different species of burreed, but we're only interested in this particular species, the branched burreed, for the purposes of NPMS. It's a fully emergent plant and it's the easiest one to identify, especially when it's in flower. When it's in flower, it has these big spikes combining almost golf ball shaped balls with lots of little spikes on, and these smaller protruding flowers coming out from the stem. It's fully emergent, doesn't have any floating leaves, unlike the other species of branched burreed. It can grow up to 1.5 meters in height, according to the books, but I've actually seen taller specimens in the wild. The leaves tend to be more than a centimetre wide, and they're triangular at the base and along part of the leaf. And the extent of how much the leaf is triangular decreases along the length of the leaf. The leaves and the stems are very spongy. When you compress them, you sort of get a very crunchy, spongy effect. And you can quite often see white cross walls on the base of the leaves and on the base of the stem if there's some material that's pulled up as well. It's usually this very bright yellowy green. From a distance, you could conceivably mistake it for glyceria, for the sweetgrass, and we'll talk about the differences in a minute. But the key element here is that the Sparganium has a sort of triangular leaf shape and a keel underneath that leaf all the way to the tip, unlike the glyceria. You might also muddle Sparganium, if it doesn't have any flowers, for Typha, that's the bulrush, but that tends to be more blue-green in colour and has flattened leaf. We'll talk a bit more about that in a moment. In the middle we have an example of one of the sedges to be recorded, Carex obtrube, and the sedges generally are quite easy to tell as a group. They have leaves that are either V-shaped or occasionally W or M-shaped in cross-section. They often feel quite rough to the touch, and in fact be careful if you run your fingers along them. It's very easy to get a cut from a sedge leaf. I've done that on many an occasion. If they're flowering, then the flower stalk stem tends to be triangular again in cross-section, and they have quite pointed tips to their leaves. Butamus, the flowering rush on the right, is very easy to tell when it's in flower. It has these beautiful characteristic pink flowers, which are often quite conspicuous, particularly along canals which don't receive much boat traffic. And they're quite often a popular plant in people's gardens. If they're not in flower, it can be quite tricky to tell whether the stems or leaves of stems of butamus are butamus or sparganium. Things to look out for are the leaves tend to be quite dark green rather than the pale green of sparganium. They don't occur in distinct ranks like the sparganium does. The leaves tend to be slightly twisted and also quite narrow. The leaves are usually less than 1 centimetre wide, and they taper to quite an acute point, although you might not always be able to see that. If you can get to a leaf and you can snap it, you find as you sort of snap the leaf and try and pull it apart, the veins are much stronger than the leaf material and they tend to stay together and stretch. So if you sort of snap the leaf and try and pull the two parts apart, the veins tend to stretch rather like pulling a stringy cheese apart, and that's quite a characteristic feature. Moving now to those plants which again are still emergent, still have narrow or linear leaves or no leaves, but this time we're thinking about the species where the leaves are quite broad and they're flattened and they all arise from the base of the plant. And we can look at how those leaves are arranged from the base of the plant, and they might be in two overlapping ranks, in which case it could be iris or acorus that we're looking at, or they might all fan out from the base below the water surface, in which case we're probably looking at a species of typha or bulrush. On the left we have Iris pseudacorus, flag iris, which we're probably all familiar with from our gardens. It's very characteristic when in flower because it has these bright yellow flowers. But it's quite possible that there won't be any flowers when you're carrying out your survey. You could also look for the characteristic seed heads, which are large, dark green and almost pear-shaped, but again it might be that you come across plant material that doesn't have any flowering material left at all. So in the absence of flowers, you're looking for flattened leaves that have a central midrib and are arranged in ranks of two, as we show at the bottom picture on the left-hand side. Just be aware that sometimes you might come across garden variations such as Iris versicolor, which have been spread into the wild. The species you're most likely to muddle iris with is Acorus sweet flag. And the way you tell that apart is that sweet flag Acorus has a displaced midrib. So rather than the midrib being up the centre of the leaf, it's displaced to one side, so it splits the leaf roughly into a third to 2/3. One side of the leaf tends to be slightly crinkled as a consequence of that, and if you squash the leaf you get a smell of orange or tangerine. So that's how you would tell that apart from iris. On the right we have the bulrush, Typha latifolia, and you can tell it's quite easy to pull out from some of the other vegetation that it might be growing with by this sort of grey-green colour. The leaves all fan out from the base, so all the leaves come up from the base of the plant, normally below the water surface. The leaves are flattened, and the plant can grow to be really tall. I mean, it can be sort of 2 meters plus. If it's in flower, which we can see down in the bottom right-hand side, it's quite easy to tell that it is Typha, and also to tell the different species of Typha apart from each other. So you need to record Typha latifolia, where the male and female parts of the flower are joined together, and it's a very robust plant. The leaves are at least 1 centimetre or more wide. When you're looking, there is this another species called Typha angustifolia, which tends to have much narrower leaves, which are less than 1/2 centimetre wide, and usually has a much bigger gap between the male and female parts on the flower. So the final group of tall stems with few leaves or flattened leaves that we're going to talk about are the group that includes all the grasses. So these comprise stems with flattened leaves which come off the stem in an alternate arrangement, and the base of the leaves usually sheaths the stem, as you can see in the picture on the left. And the first species we're going to consider is Glyceria maxima, or reed sweetgrass. And this is the only species that you need to record for wildflower or indicator level. So it's a classic grass. It's got its leaves coming off the stem alternately. The leaves are slightly flattened, but the key element is that they are what's called boat-shaped, which I've tried to show in this picture on the right. So that if you hold them up on their side, look at them sideways on, they are keeled and look like a classic end of a prow of a boat. And that's how you would tell them apart from Sparganium, which has a very flattened leaf surface, but with a triangular leaf shape. Glyceria can often form really dense stands, either as an emergent species, as I've shown in the pictures here, but if you come across disused canals which receive very little boat traffic, you can sometimes find the Glyceria forming floating mats which cover much of the water surface. Other grass species that you might muddle it with when you come across when you're recording at the edge are Phragmites common reed on the left, or reed canary grass Phalaris arundinaceae on the right. So on the left we have Phragmites, which is a very tall reed, often found in wet areas as well as along the edge of water. And the leaves here come off the stem alternately, but they're not fixed to the stem. And that means when the wind blows, it tends to act to blow all the leaves in the same direction, so that you end up looking almost like a whole series of flags with all the leaves arranged on the same side of the stem. If you pulled one of those leaves back from the stem, you would see that the ligule is reduced to a series of sort of hairs looking a bit like an eyelash. And that's how you would distinguish it from the other grass that's common along the edge of waterways, Phalaris, which tends to be a bit shorter, a bit less robust than Phragmites. But if you look at the picture right on the far right, you can see the ligule of Phalaris, which is very membranous as it clasps the stem. Okay, having looked at all these plants which have either bare stems or stems with flattened leaves, we're now going to look at those emergent plants which have broad leaves or divided leaves. And within the broadleaves, we're going to look particularly at three species. We're going to look at Alisma plantego aquatica, which is water plantain, Rumex, which is water dock, and the wonderfully named Veronica beccabunga, which is commonly known as brooklime. And then we're also going to look at three species which have divided leaves, and that's Apium nodiflorum, which is the fool's watercress, Berylla erecta, which is lesser water parsnip, and Nasturtium officinale, which is watercress itself. So starting off with those broadleaf species, we have the water plantain, Alisma plantego aquatica, on the left-hand side, and Rumex is on the right-hand side, and both have very broad, erect leaves which arise from the base of the plant, but they're very different in size to each other. Alisma can be quite easy to identify, but it can often be overlooked, particularly when it's growing amongst other dense emergent vegetation. So this example that I'm showing you in the picture on the left is still there. That plant's still there. It's at a site that I've monitored over the last 10 years, but it's actually quite tricky to see because the leaves get hidden by all the other emergent vegetation that's grown up around it. It produces stalks of white flowers, which are quite characteristic, but they're only there for quite a short period of time, so it can be quite tricky to see. There are other species of Alisma that you may encounter, but they tend to have much narrower leaves, so you're less likely to get them muddled. Rumex is a very tall, robust plant. It's often found with its feet barely in water, I would say. Unlike the Alisma, which you can see is actually growing in the water's edge, Rumex will grow right at the water's edge, but it will also grow up the bank a little bit. Has very tall spade-like leaves, which I've seen sort of grow probably a good sort of foot to 2 foot in length. The edges are slightly crinkled and twisted, and to me it reminds me of a very robust dock or very robust horseradish. The next species with broad, roughly entire leaves is Veronica Beckabunga, Brookline. This is a sort of quite small plant which grows on the margins and into the edges of water. It can often forms sort of procumbent spreads from the land over the water surface. It's quite fleshy leaves in pairs, and the leaves are sort of oval to rounded in outline, but with small teeth. The whole plant's very fleshy, the leaves are very fleshy, the stem's very fleshy, and it can often have these little bright blue, electric bright blue flowers, which are very conspicuous in the margins of the watercourses. We come now to 3 plants which all have leaves which are divided into sections or lobes, and they can sometimes lead to some confusion. So we have plants which have got a terminal leaflet which is wider and larger than the rest, and an entire leaf margin, and that's watercress, Nasturtium aquaticum. And that can sometimes be muddled with the false watercress, Opium nodiflorum, on the right-hand side of the diagram, which has a terminal leaflet which is the same size as the other leaflets or is much deeply lobed. And Apium also can be muddled with lesser water parsnip, Berylla erecta, which has a ring on the leaf stalk below the lowest pair of leaflets. So we'll just look at those 3 species in a bit more detail and start off with this distinction between the Berylla, the lesser water parsnip, and the false watercress, Apium nodiflorum. So here we see the lesser water parsnip, Berylla erecta, and fool's watercress, Apium nodiflorum, side by side. They are both members of the carrot or umbellifer family. When in flower, they're relatively easy to tell apart, but there can be confusion between them if you've only got vegetative material to look at. So they've both got similar pinnate leaves, that is a main leaf stem with little leaflets off. And if you look in the different identification books, some give you guidance as to the different number of leaflets that might be found on each leaf, depending on which species you look at. So some books say that Berylla might have 5 to 10 leaflets, whereas other books say that they might be up to sort of more than 10 leaflets. And I've seen books that say that Apium can have up to 13 leaflets. So there's a great deal of overlap, and there's also variation depending on which book you look at. So I'm not sure that that's going to be a particularly helpful characteristic for you. Perhaps the best thing to look for is what's known as a characteristic discoloured ring, which occurs on the Berylla erecta leaf stems just below the lowest pair of leaflets. So if you manage to find a leaf of Berylla, look below on the stem below the lowest pair of leaflets, and you should find a discoloured ring, and that will help distinguish Berylla from Apium. On the right we have the fool's watercress, and we're going to talk in a minute about true watercress, but one of the ways that you can tell the 2 species apart is that both Apium and Berylla have sheathing leaf bases, whilst the true watercress doesn't have a sheathing leaf base. Also, if you look at the leaf shape here in the Apium, you'll see that the leaflets have teeth, effectively teeth on the edges of the leaf, and when we go and look at the watercress, you'll see that the edge of the leaf for that is pretty much entire. Having looked at the false watercress, we'll now move to look at the true watercress. Nasturtium officinale. If you have one of the older books, you might see it called Roripa Nasturtium aquaticum, and that's exactly the same species. So this is a member of the cress family, and that's very obvious from the flowers shown on the left-hand side of the picture. As this is cress family and false watercress is a member of the carrot and parsnip family, true watercress doesn't have that carroty parsnippy smell that is often associated with the false watercress. Other ways to tell them apart when not in flower are by looking at the shape and the size of the terminal leaflet, which you can see in the right-hand picture on the slide. So in watercress, this terminal leaflet tends to be larger than the others on that leaf compared to apium, which tends to have all its leaflets at about the same size. And also if you look at the edge of the leaf here, you can see that it's broadly entire in the true watercress, whereas in the apium it was very toothed and divided. Well, we've gone through a lot of emergent species there, so it's worth just having a brief stop and a recap of some of those species to see what you can remember. So have a little think and see if you can remember what is plant A. Do you recognise plant B? What is the name of plant C? Can you identify plant D? What about plant E? And finally, plant F. So plant A is the flowering rush, Butamus umbellatus, characterised by these bright pink umbels, and bonus point if you picked up that we've got iris leaves in the background and an iris seed head just to the left of the Butamus plant there. Plant B is one of the grasses that we talked about, reed sweetgrass, Glyceria, and it's got the leaves coming off the stems alternately. Plant C is bulrush, Typha latifolia, with its broad, flattened grey-green leaves all fanning out from the base of the plant below the water surface, and these very characteristic cattail flower heads. Plant D is our water horsetail. That's our stem, bare stem with very few branches coming off it, and the stems divided into little sections separated by little crowns. Plant E is mare's tail, which we've seen several times throughout the presentation, with these little characteristic Christmas trees rising above the water surface. And finally, plant F is branch burreed, Sparganium erectum, which has leaves in ranks of tube, triangular leaves extending along the length of the leaf in cross section, and very spongy in texture. Now we've gone through all the main species of plants that I wanted to introduce you to, there are a few summary points I just want to cover. Firstly, I just want to highlight those species which are considered as negative indicators for the purposes of the NPMS. We've already met most of these as we've gone through our presentation, apart from the first one shown on the top left-hand side of the slide. This plant is called Crassula helmsii, or New Zealand pygmywort. It's one of a number of introduced non-native species to Britain, and this is a very invasive species, and once you get it into a site it's very difficult to eradicate it. Part of its success is due to the fact that it can grow both in deep water as well as shallow water, and can grow on dry land, and this tolerance of different water levels means that it's able to spread between sites very readily. It's a very robust plant, and it's quite characteristic when you see it. So it's quite fleshy. It has leaves in opposite pairs which don't have any stalks. And as I've said, you might find it growing in water several metres deep, all the way through to the margins, as shown in the picture on the left there, or onto land. The first time I came across it, it was in a pond that had been built as part of a National Garden Festival, and it was an accidental introduction there, so it's very easy to introduce by mistake into sites. The only native species that you might possibly think model it with would be the Calitrichae, the water starworts, which also can grow on areas of mud and into deeper water. But these, which also have opposite pairs of leaves, but the Calitrichae leaves always have a little notch at the end of the leaf, and in some species, in fact, these notches are so well developed that the ends of the leaves look rather like miniature spanners stuck to the stem. In the middle top of the slide, we have Glyceria maxima, reed sweetgrass, and this is a native species, but it can form very dense dominant stands in water bodies, especially those with a very slow flow, and it's quite often found in disused canals or canals which don't get a lot of water movement, where it'll form very dense mats across the water surface. On the top right of the slide we have Myriophyllum aquaticum, parrot's feather, which we've talked about already as having whorls around the stem in groups of 5 or so leaves, and that each little leaflet looks rather like a feather stuck to the stem, and it has this very bright electric green colour. In the bottom left hand side of the slide we have Azolla folliculoides, the water fern, which is one of these free floating plants that's not rooted. It has a crinkled, divided outline to the leaf edge and can often go quite red in colour, particularly towards the autumn and winter. And on the bottom right of the slide we have the waterweed, Elodea canadensis or Natalii, which we've talked about as having whorls of leaves in groups of 3 around the stem. Well, thanks everyone for sticking with the training so far. Just to finish off with, I thought it might be helpful to bring together some of those things we've been talking about, some of those plants from the different habitat zones and growth forms, and tie them back with the fine habitat type. As I said, I think it'll be easier for you when you're out and about surveying to record the species first and then use those species against the list that you're provided with by NPMS to decide on which fine habitat you were in. But just as a little refresher, here's a photo of a site, and we have a selection of species that might be associated with a water body of this type, and another view of the sorts of vegetation you might find. Have a little think and tell me what you think you're seeing in terms of the species and which fine habitat it might be. This is an example of a nutrient poor standing water body, nutrient poor lake. Clues to look at: firstly, the topography gives us an indication that we're in a more upland area. Looking at the main picture on the left, we've got some Chenopelactis lacustris, common club rush, in the foreground. That's the tall emergent plant in the foreground. Behind that we have white water lily with its rounded leaf outline, dark green leaf colour with some tinges of red that we can see in places, and in the background we can see some common reed, Phragmites australis. Other typical species that might be associated with nutrient poor lakes are shown on the right hand side of the slide, and at the top we have Lobelia dortmana. This is one of our rosette species which doesn't have runners. The leaves are slightly recurved, they're more rounded at the tips, and if we snapped a leaf and looked at it in cross section we would see 2 hollow parallel tubes. Next to that we have another rosette growth form, the Isoetes lacustris quillwort, and that's the species which has the little white cross walls. The leaves tend to be quite crunchy, perhaps slightly reminiscent of celery in texture and in shape at the base where they join the rosette. Below that we have a picture showing some sedges, again in a nutrient poor lake, and the bottom picture is of bogbean, Menyanthus trifoliata. Okay, in a similar vein, have a look at this collection of photographs and decide what sort of fine habitat you think it might be and what are the sorts of species that you're looking at. Yes, this is an example of a nutrient-rich lake. We can see it's got very lush vegetation with lots of marginal vegetation and emergent vegetation extending out into the lake surface, covering large amounts of the surface area. Some of the characteristic species in the top right, we've got Littorella shoreweed, which is heavily covered with algae, and again algae is another indication that we've got a nutrient-rich site. So shoreweed, Littorella, is one of the rosette species. It's linked together by runners to form very dense beds. The leaves are quite spongy and slightly pointed at the tips. In the middle, on the left-hand side, we have a picture of the fen that you might find around a site such as the nutrient-rich site. We've got some water mint, Mentha aquatica, that is shown in the picture there. And on the right in the middle, we have Potamogeton crispus, the curled pondweed with its very characteristic wavy edge and teeth along the edge of the leaf. And in the bottom picture, we're showing dense emergent growth again, very lush growth. And on the left of that picture, we can see some yellow water lily, Nuphar lutea, with its oval light green leaves and yellow flowers. I think that's branch burreed, Sparganium erectum in the background of the photo. And on the right is arrowhead Sagittaria sagittarifolia rising above the water surface. And finally, again, have a look at this photo and the accompanying pictures and let me know what you think might be the fine habitat type. So we have an example of running water, a river in this case, and we've got the beds of water crowfoot, ranunculus spur, visible in the main picture, and then on the right hand side from the top we have our Berylla erecta, lesser water parsnip. We have our Butamus umbellatus, the flowering rush in the middle picture, with also some glyceria it's hiding behind some glyceria, and Sparganium erectum, the branch burreed, at the bottom. Well, that concludes the training session. The next few slides, if you wish to look through them, contain some suggestions of reference material that you might find helpful in your journey venturing into the world of aquatic plants. Good luck with your paddling, and I hope you enjoyed looking at your Potamogetons.